Lesson 6-1, Types of Angles. A ray is part of a line that has one endpoint and continues forever in one direction. To draw a ray, make an arrow to show that it goes on forever. Two line segments or two rays that meet at an endpoint form an angle. An angle that forms a square corner is called a right angle. Some angles are smaller than a right angle. Some angles are larger than a right angle. These angles are named with the letter in the corner, V, W, X, Y, Z. Which of the angles are right angles? So remember, if we look up here, a right angle is one that forms a square in the corner. So the only one I see that has a square would be angle W. Which of these angles are smaller than a right angle? So remember, if it's smaller, it means it's kind of closed. So V does not look smaller. X looks smaller. Y looks smaller. And Z doesn't look smaller. Which of the angles are larger than a right angle? So the ones that are open more. So definitely V. And then we could pick Z. Okay. All right, let's double check that we used them all. V, W, X, Y, Z. Yep, we used them all. Okay, now to the other side. Okay, this says, describe triangles by types of angles. Triangles can be described by the types of angles they have. In these triangles, one angle is a right angle. In these triangles, three angles are smaller than a right angle. In these triangles, one angle is larger than a right angle. Okay, so let me just say that again. So these all have one right angle. If you look at these, all of these have angles that are smaller than right angles. They're called acute angles. Okay, all of them are smaller than a right angle. And then on these, it says one angle is larger. So this one has the large angle there. The other two are smaller. This one's a larger angle, obtuse. We have an obtuse angle, see? And we have an obtuse angle, all right? Use triangles K, L, and M for exercises 4 through 6. K, L, M. Which triangle has one right angle? We would say M because we can see that little square that makes the right angle. Which triangle has three angles smaller than a right angle? Well, if I look at L, I see how wide open it is, so I know it couldn't be that one. So I'm going to look here. I see smaller, smaller, and smaller, so it's got to be K. Which triangle has one angle larger than a right angle? I'm going to go with this one, like we talked about. I see that that angle is larger. These two are smaller, but that one's larger, so I'm going to go with L. This page says, describe triangles by number of sides of equal length. You can also describe triangles by the number of sides that are of equal length. In these triangles, the three sides are equal in length. Okay? In these triangles, two sides are equal in length. So see, we got two long and a short, two that are the same and a long, two, and then see that. Okay? In these triangles, no sides are equal in length. So all the lengths are different. Okay? Use triangles B, C, and D for exercises 7 through 9. Which triangle has three sides of equal length? Well, probably the one that's more pleasing to the eye would be C. As you can see, all three sides are equal. Which triangle has two sides of equal length? Be this, kind of like a pennant here. See, these two are the same, and that one's different. So D. Which triangle has 0 sides of equal length? This one, you have 3 different sizes. Okay, you can just kind of offhand see just by looking at it too. Okay, all right, this side here, it says, describe triangles by types of angles and number of sides of equal length. Use triangles M, N, and O for 10 through 12. Write M, N, or O, then complete the sentences. Triangle blank has one angle larger than a right angle and has blank sides of equal length. So let's find the one that would have one angle that's larger than a right angle. So it couldn't be this because there's a right angle. This, it looks like they're all smaller, so it's going to be this one. So we're going to say triangle O has one angle larger than a right angle and has blank sides of equal length. Looks to me like it has no sides of equal length. This is super long. It's the shortest. That one's in between. So I would say 0. I'm going to put a line here so we know the difference between O and 0. You don't have to, but kind of helps. Triangle blank has one right angle and has blank sides of equal length. Well, the only one with the right angle will be M. Let's see how many equal sides. I think 1 and 2. Looks like 2 are equal, and then that one's longer. So 2 sides of equal lengths. Triangle blank has 3 sides smaller than a right angle and has blank sides of equal length. Well, the only one left is N, and we can see they all have 3 small angles. And how many sides are equal? Looks like maybe just 2. 2 sides are equal. Okay, use triangles PQ and R, right? PQ and R, and then complete the sentences. Triangle blank has 3 angles smaller than a right angle and has blank sides of equal length. So it's just like the last one, I guess. So which one has 3 angles that are smaller than a right angle? This one looks like it's a little bigger, so I would say, let's see. So it looks like there's 2 that could work, because see, this one says has blank. So it could be either 1 for 13. So it looks like it could be either Q or R. So we could just say Q for this one has 3 angles smaller than a right angle and has blank sides of equal length. Looks to me like on Q it has 0 sides of equal length. Well, it kind of looks similar, huh? Triangle blank, so we could say R has 3 angles smaller than a right angle and has, I would say 3. It looks like all 3 sides are equal. Then the last one, triangle P has 1 angle larger, I would say that one is, than a right angle and has 0 sides of equal length. It's a long lesson, huh? It's just because it takes up a lot of space. Build quadrilaterals from triangles. Cut out each pair of triangles. Okay, so basically they wanted you to cut these out and go on a separate sheet of paper and make new quadrilaterals, which we did spend a lot of time doing that in class. So you can either do it if you want to, or you can skip it. Polygons. Polygon is a flat closed figure made up of line segments that do not cross each other. Very important, they do not cross each other. Okay, circle the figures that are polygons. That is not, because it crosses. This is a polygon, definitely not a polygon, because it has to be flat closed figure made up of line segments. I don't see line segments there. Polygon, this is not, because it is not closed, so that is not a polygon. This is not a polygon because it is not closed. A figure can be concave or convex. In concave polygons, there exists a line segment with endpoints inside the polygon and a point on the line segment that is outside of the polygon. A convex figure has no such line segment. So this is concave and convex. Okay, so which are convex and which are concave? We can kind of see by looking, concave looks like something's caved in a little. So 24 we're going to say is convex, because I don't see anything in, I only see it pointing out. 25 will be concave. 26 concave, right? You see how we have these little concave areas here? And this would be convex. Okay. Name polygon. So here you go. You basically just count the number of sides they have and then you can name it. So 1, 2, 3, 4, 5, 6. This would be called a hexagon. It's 1, 2, 3, triangle. 1, 2, 3, 4, 5, pentagon. Sorry, my writing's weird. It's an awkward box thing I'm using. 1, 2, 3, 4, quadrilateral. Remember, a quadrilateral is any shape that has 4 sides. Quadrilateral. Okay, now with these, you might want to mark where you started. That way you know not to count it again. 1, 2, 3, 4, 5, 6, 7, 8. Octagon. Octagon, excuse me. In Greek it is octo, but in English it's octagon. Okay, 1, 2, 3, 4, 5, 6, another hexagon. 1, 2, 3, 4, 5, another pentagon. Looks like a house. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, decagon. In Greek, deca is 10. Okay, and 1, 2, 3, 4, 5, 6, 7, 8, another octagon. So as you guys can see, you can have the same name of a shape, but they look different because their lines are different lengths, right? Okay, build polygons from triangles. You're supposed to cut those out and build your own, which I feel like we spent a lot of time on as well. Okay, and that's it. Stay tuned for lesson 2.